Hi.
Come on in.
Make yourself comfortable.
In the future, should we close the door or do that make it worse?
I'm going to kind of leave it sort of half shut. Half I'll be watching.
Okay. I know if it's cooler in the hall than it is. Okay, I'll get started. Let me introduce myself. I'm Rick Caplan. I'm a statistician at Christiana. I've been there for a year. Before that, I was at AstraZeneca for a long time. And before that, I worked at some cooperative oncology groups. Most of my experience is with randomized clinical studies. But in the past year at Christiana, I've worked on everything except for randomized clinical studies. A lot of the research within the hospital is based on trying to improve care within the hospital. So I've not worked on any treatment studies since I've joined Christiana. Now on the slide, you'll see I want to acknowledge Paul Neitert's slides. Most of the slides, especially the good ones, are from Paul. Paul did a talk where he was talking about collaborating with a statistician, working on a grant. So a lot of the slides are about a longer-term working relationship on a bigger project. But it's good to know this because even though you may be working on a small project, someday you may be working on a bigger project, a longer-term project. So it's kind of nice to know, the full scope of what a statistician does. Paul is another statistician who's linked to CTR Excel grant. That's a grant that covers 4 institutions. It's Christiana, the Moores, where I'm sitting right now, University of Delaware, and Medical University of South Carolina. And Paul's actually in South Carolina. He's an excellent statistician. Go on. The messages that I hope you come out of this are that if you do consult with a statistician on the project, please do it early. Don't go all the way through the project and at the very end ask for p-values or something. Get involved with the statistician early. Even if it's a brief consult, even if the project's easy, it's best to do it early. And the second message is you should consult with a statistician on a project. For you folks, you're here and you're aware of Excel, that multi-year grant, it's really easy. On the website, that's Delaware, DE-CTR.org, there's a request for at the Biostat. You just have to submit a request. We meet every week to discuss the new requests. Right now, because we seem to have the resource, virtually all requests are accepted. And the request could be for a brief consult or for a longer-term involvement with the project. It doesn't matter. You just tell us what you need. But it's really easy to ask for help, and it's free. So it's already paid for by the grant. So take advantage of it. There's statisticians at the Medical University of South Carolina. There's statistician and epidemiologist at the University of Delaware. We have several statisticians at Christiana and a few statisticians here at the Moores. Among the group, what we do not have, one area that we found we don't have any expertise among the statisticians is for qualitative research. Like some of the studies within the hospitals are interviews, something where they actually analyze the text of an interview, something called the Delphi method, where they go back and forth and iterate to some sort of resolution. I am completely unfamiliar with qualitative research, but within the network of people we know, we can usually find help if you're doing a qualitative study. So there's people that are on the call every week, but then they know people within like the University of Delaware or South Carolina who can help with things that we don't cover, like qualitative research. But one way or the other, we've always been able to find help for people who ask for it. as I say, most of my career I've been working at AstraZeneca, randomized clinical studies. They have to consult with statisticians early on when they're writing a protocol. And for people who don't work a lot with statisticians, one thing they'll always ask for is sample size. And the other thing they'll ask for is some analytic statistics and p-values. But I wanted to make the point here that besides sample size, we do want to talk about other aspects of the design, because the way a study is designed leads to any sort of statistical analysis you can do at the end. And also, I do want to be involved in reviewing the presentation. Even if I'm not a co-author, I want to make sure that the results of any analysis are accurate and accurately representative, and they're interpreted properly in the presentation, whether the presentation is a manuscript or an abstract or a poster or an oral presentation. Mostly when I've worked with investigators, they've been physicians. And I wanted to start by saying, when I'm looking out, I've worked with different kinds of investigators, physicians. One type is someone who's really knowledgeable, not only about the clinical area, of course, but also about statistics. Like I've worked with several physicians who have MPHs, and they have studied statistics, and they have a real interest in statistics. The good things about this is that if they have a particularly tricky study, they may have already done the literature review, read similar research, and actually come forward with some ideas about how the analysis should be done. And it may be something I'm not familiar with. That's great. It saves me doing a literature review. The things I have to be cautious about is that sometimes people will read one paper and say, oh, this is the way to do it. Well, you know how broad the literature is. There's often more than one way to do something, and something that was done in one study before may not be appropriate for the particular study in front of us. I worked with one physician who suggested using, and it was properly suggested, to use propensity scores. I hadn't used propensity scores before, and he'd had consulted with somebody on another project where they talked about propensity scores. What propensity scores are is that if you have an endpoint, you're comparing two groups, let's say, if you have 3 or 4 or 5 variables you want to adjust for in a regression analysis, that's fine. But if you have 30 or 40 variables, that's going to overwhelm any model. And one way to approach it is to sort of collapse those variables into one number called a propensity score. You lose information, so there's always some sort of a balance, but it is one approach. And he had one approach of using propensity scores, which is fine, but subsequently I've talked to other people in other studies, and it turns out there's lots of ways to use propensity scores. So coming forward with one paper, it's maybe a starting point, but it may not be the answer. And this is for myself. When I talk to somebody who really is interested in knowledge about statistics, I have to make sure I'm not led down the road too far where I actually have to back up and sort of figure out if that was the right way to go to begin with. At the other end of the spectrum for investigators is somebody who's completely bored with statistics. Thinking of visualizing another physician I worked with who's a great physician, very personable. Sometimes when I talked with him, I thought, I wish you were my doctor. Why are you working here? He was a really good doctor. He had no interest whatsoever about statistics. Well, he trusts me, that's good. But the problem is when a study is presented, like with an oral presentation or a poster, it's usually, in this case, the physician who's going to be doing the presenting. And I want him to be able to answer questions. People are going to ask about the clinical content, but they're going to also ask what was done. And he has to know enough to be able to answer those kinds of questions. And I don't want him to stumble around. So I want him to be at least a little bit interested and to understand, what I've done. And of course, the happy Goldilocks medium is a collaborative relationship, which has the best chances of success. It takes a little more time, but I think there is a payoff. Collaboration, working with each other to do a task. There is a back and forth where people work together towards shared goals, and it's part of a team. And I'll say that I'm used to this more in the pharmaceutical industry, where in the early days, it wasn't so well organized, but by the time I left, everything was very team-oriented. I mean, every study from its inception would have a team defined, cross disciplines, and you didn't have to ask for a seat at the table. Statisticians, physicians, somebody from regulatory affairs, everybody was at the table, and so it was very team-oriented. So I'm used in that environment, in a collaborative relationship. Here I have to actually work at it a little bit more because some people are used to working with statisticians, some not so. Pillars of strong collaboration: communication, clear expectations, respect and trust, productivity. Communication. Face-to-face meetings are key. Now, again, I worked at AstraZeneca, and over time, when I started many years ago, it was a site in Wilmington and a site in the UK. And it grew to the merged AstraZeneca, where there were sites in Sweden. When I left, I worked on a diabetes project. We're working on a drug that was developed at BMS. And so when we had a meeting, it was usually a teleconference. There could be somebody from AstraZeneca in Wilmington, AstraZeneca in Sweden, someone from BMS. And then we also worked with a small company that developed some of these diabetes drugs in California called Amylin, which BMS took over. Now, between California and Sweden is 9 hours. And so there was like a 1 hour time slot during the day when you could have a teleconference. We were forced to have teleconference. But teleconferences are fine, but it's good at the beginning of a long-term project to meet the person face-to-face. It makes teleconferences, video conferences after that much. Biostatisticians want to develop knowledge, should be developing knowledge in the science of that particular project so that they can work with the investigator better. And the investigator should make some attempt to, as I mentioned earlier, to understand the relevant basic concepts so that they can speak to them if asked. Communication, just a point. In our discipline, a large proportion of statisticians don't have English as a first language, so please be patient. They're good statisticians. We have a lot of good statisticians at Christiana here, everywhere, but English may be the second language, so just be patient with that. It's good to have a plan of action. In the pharmaceutical industry, we had to write a statistical analysis plan that had to be accepted and at times signed off by the rest of the team. So everybody agrees this is the analysis going to be done. It's a regulatory environment, and for large pivotal studies, actually the FDA requires a statistical analysis plan to avoid data dredging after the study is done, data mining, looking for a positive result. They want to know ahead of time, before the data are in, what your primary endpoint is, how you're going to analyze it. There could be exploratory analysis after that, but they actually want to see the plan on paper before the data are in. It's not required where I work now. I still try to sketch out an analysis plan so that there is some agreement with the investigator about, do we have a common understanding of what the hypothesis is and what the analysis will be. And for a longer term project, the timelines are important, the funding if it's a grant, and authorship. Right, come on in. Come on, I started. Yes. Please sit up. Okay, I did start already, so you're picking it up. These are, place it out. Okay. And we're into talking about some aspects of a collaborative working relationship with a statistician. Respect and trust. Statisticians obviously respect the colleague's time is limited and valuable, and non-biostatisticians, please recognize that we don't come in necessarily with a knowledge of the area, and also we're not technicians, so don't just say, give us some p-values. We do need to understand the project because the study design is what leads to valid statistical analysis at the end. Don't put our name on a paper without our approval, but I'll say also review. I want to be able to review any publication, or publication can go from the presentation all the way through to a manuscript, and be willing to take constructive criticism. Statisticians, academic statisticians, will often look for opportunities to go further and develop some methodology that is part of their academic career, and look to the investigator to help support that effort if the statistician does find something interesting in the project to go further. And both parties should look for win-win situations and realize that each has different motives and sees different things in the project. This is Paul, who made a lot of these slides, giving a warning to the statisticians: be careful not to overdo the analysis. Sometimes simple analysis are sufficient, but some studies, they may be a little bit more complicated. Be patient with the statistician if they're looking for something that is more appropriate for that particular study. I used to work at AstraZeneca and had the same message over and over again. Pick up the phone, don't just send out emails. It is better to talk through rather than email if you can do that. And if you are giving a presentation like this one, I credit the person who made a lot of these slides and recognize the role the others do. Productivity, this is for a longer term project. Both sides work hard, make commitments, fulfill the commitments, and future promotions and grant funding depend on it. Be productive. This is his message to the statisticians: don't fall into the temptation of diving deep, data mining, reanalyzing in order to find a significant p-value. Well, this is where I am adjusting, because I've worked at Christiana for a year, but before that I worked a long time at AstraZeneca, which is a regulatory environment. And there I was saying that for the pivotal studies, we need to pre-specify what the analysis will be for the important endpoints. There can be exploratory analysis after that, but for the important endpoints, we need to actually pre-specify it. I'll go a little bit further, since you may be working on drug studies or know about them. When I first joined many years ago, the rules at the FDA for a pivotal study were: the study needs to be a positive study, which means that there is a significant value distinguishing two treatments for the primary endpoint, which has been pre-identified. If the study is positive, they'll be willing to look for other positive information in the study and put that in the label. Now, putting things in the label, in a drug label, is important because a pharmaceutical company can promote positive things that are in the label. If it's not in the label, it may be promotable, but it's a negotiation about whether it can be promoted or not. But if it's positive and it's in the label, you can promote with it, and you really don't get pushback from the FDA. So getting a good label is very important to a pharmaceutical company. Things have changed over the years because the FDA statisticians, I think, felt that they were always getting a lot of pressure from the company, put more and more and more stuff in the label. And so in recent years, what they do is, if the pharmaceutical company wants something in the label, besides the primary endpoints, some secondary endpoints, they must control for multiplicity. Now, what that means is that anytime there's a clinical study, you don't just do one test, one p-value. Clinical studies are rich. There's a lot of information in clinical research, as you know. If the pharmaceutical company wants 2 or 3 or 4 things potentially in the label, they must pre-specify it and control the statistical analysis for multiplicity, which basically means since you've got several chances to get a positive result, you must make the tests more difficult. So instead of saying a test is statistically significant at a 0.05 level, it might be significant at a 0.01 level. There are a lot of methods for adjusting for multiplicity, but the sponsor, the pharmaceutical company, now must make a decision ahead of time. They're going to try to get this stuff in the label, 3 or 4 or 5 different things, but there has to be a penalty. You have to control for multiple comparisons. Non-biostatisticians try not to keep telling the statisticians to keep looking if they can't find something significant. We're trying to do things as valid as possible. So statisticians, biostatisticians get involved throughout the whole project, from the study design all the way through to the publication or writing up the results. An obvious thing at the very beginning for the study design is the sample size, the statistical power. But the design itself is important because the way it's designed can lead or not lead to the analysis that you'd like to have later on. It's good to have something on paper and state ahead of time that everybody agrees this is the hypothesis we're trying to get from this study. It's good to justify why you have this particular study design. I wrote down the sampling scheme because I want to remind that anytime you're doing a study, you're not just looking at the data, well, you are looking at the data from that study, but you're trying to generalize. You're trying to learn something bigger than just that study. And sometimes people, forget that because when the study's done, you say, this group's different than this group. Well, the 2 groups are always different. It's whether you can draw inferences about a larger population, trying to generalize the results of the study. Collecting the data, we do have some interest in having good quality data, not having missing data. Through Excel, through Moores and Christiana both, we have a system called RedCap, where we can use it to collect data. It's used for survey data, but it's actually pretty general, can be used for a lot of things, and it's really good. It's very nice. I know in the hospital we have a lot of studies that are surveys. And saying, I'll do Survey Monkey. Well, you can use RedCap. It's actually better quality than Survey Monkey. You can do a lot more with RedCap than you can with Survey Monkey. Analyzing the data, of course, statisticians are involved with that, and interpreting the results. And as I mentioned before, I do want to be involved in the final presentation of the results. Even if I'm not a co-author, I want to make sure that the numbers are accurate and the interpretation is accurate. And for a manuscript, of course, we'll help write up the statistical method section. I keep referring back to the pharmaceutical industry, but there we would always have a statistical analysis plan ahead of time. And we have the luxury of having a medical writer who could write publications or reports. They actually would just copy and paste from the statistical analysis plan into a final report or adapt it to a manuscript. So things that are written up ahead of time should still be valid when you're done with the study. And of course, I want to check with the interpretation of the results. Trying to see if I had any other notes here. I guess I did want to mention a study about why it's good to be involved with the design of the study that carries through. There's some studies that on the surface seem simple. Like right now in the hospital, right now at Christiana, they're displaying results of studies that have been done within various units throughout the hospital. It's called Focus on Excellence. And there's 155 posters right now at Christiana showing various kinds of studies within units, just trying to improve quality, reduce errors, reduce costs. Some of the studies are survey studies. Some of the studies are simple before and after. That is, there's going to be a process change. You survey or you measure something before, you measure something after. It's very simple. But even in simple studies, things can go wrong. So I worked on one study where on paper, I'm not sure it was written down, but on paper, it looked very simple. They looked at patient satisfaction surveys, these health HCAP surveys before process change, and then HCAP survey after process change. But the thing is, it spans several years. And in a hospital, it's not a static environment. There's a lot of things that can influence patient satisfaction over a course of several years, not just the process that's being changed. And so in the end, they could descriptively show what they found with the surveys, but they really couldn't make a conclusion. They could not conclude that this process change affected patient satisfaction because there's 100 other things going on in a hospital over the course of the year trying to improve patient satisfaction or cost or quality. Talk a little bit about study design. Once a hypothesis is defined, a statistician wants to help with estimating the sample size. You mentioned several things about how certain you want to be of a difference. What difference do you expect to see between a couple of groups? How much variability do you expect to see either from a previous study or from the literature? So this is the way statistical hypotheses are set up. You've seen them before, but it's a little bit awkward, but the idea is that a hypothesis is innocent until proven guilty. So innocence is, if you're comparing two groups, the two groups are the same. And when you talk about the two groups, it's not the two groups in your study, it's the populations. It's the broader population. A study is usually a sample from a broader population. And if the null hypothesis is false, that is, the groups are really different, and if you've rejected that null hypothesis, that's good. If the null hypothesis is true, but you failed to reject the null hypothesis, it's worked. But if the null hypothesis is true, that is, the groups really are very much the same, the populations are the same, but you have rejected the null hypothesis, that's one kind of error that has been made with this particular study, called type 1 error or an alpha error. And the other is if the null hypothesis is false, the studies, the populations really are different, but you fail to reject it, well, you've made another kind of mistake. 2 error, beta error. So in designing, even just doing sample size, the statistician is going to ask for some basic information to help say how many patients, how many subjects, are needed to do a statistical test. Alpha is the probability that it's an error, that we rejected a true null hypothesis, and 0.05 is often used. It doesn't have to be used, but it's often used. And beta is the probability of failing to reject a false hypothesis. Sometimes it's because the study is just too small. Just with variability and stuff, the populations may be truly different, notably different, but you failed to do a study that found that difference because it wasn't big enough. 1 minus beta is the statistical power, and 80 or 90% is often used for statistical power. And all this is tied together in doing a sample size estimate for the study. One thing that the statistician will try to talk with you about and get is the minimally important difference. So as an example, if a mean difference in two populations, opioid use of 0.05 milligram between the control and the treatment groups Is that meaningful? But if you find a difference of 0.3, I think I meant 0.03 in here. Is that scientifically meaningful? Look for 0.03 there. Sorry, I think I made a typo there. The reason we need to know how big of a difference you want to find is that a large difference, easier to find a large difference between populations. So the sample size will actually be smaller. Small difference between the curve on the left is supposed to represent a distribution for a null hypothesis, like the difference between two groups, which is centered on 0 with variability. And then the other is a difference of, I'll say, 3 between two groups, which is centered on 3 with its variability. But there's variability. That's why statisticians are involved. There is variability. So no certainty in getting the results you want. But the smaller the difference, the larger sample size is going to be required. But the other thing we will ask you about variability, because the more spread out that distribution is, either the null hypothesis or the alternate hypothesis, the more difficult it's going to be to find it, the larger the sample size you need to overcome that variability. So all these factors are needed to estimate the sample size, the significance level, target, statistical power, difference you're trying to find. You need a good estimate of the variability, either from the previous study or from the literature and the actual study design. And what I was saying earlier about multiplicity, if there are several endpoints, and if you want to control for multiplicity, which will help make a very solid conclusion about more than one statistical hypothesis, often we will lower the significance level from 0.05 to a smaller level, lower p-value, higher bar to declare statistical significance. So for a successful relationship with your biostatistician, prepare to discuss your research question, the outcome, the plan, the study design, comparisons you want to make. You need to define all those hypotheses, hopefully up front, the data that you're going to be collecting, the variables of interest, and more, the significance level, the power, the differences that you would like to be able to see, and what sort of variability you expect. And we're not experts like you are, so give us a little time to understand your project, science behind it, and the research goals. We should be able to help. And this is a caution, the last slide. No, that's not there yet. The best time to include a statistician is early. So we really want to be involved in the design part of it. Even if it's obvious from your point of view, even if it's simple, no harm in touching base with a statistician early on. Because in the end, we all want to get valid study results. And this is the last words. Fisher was one of the fathers of statistics in the early 1900s, one of several. But he said calling in a statistician when the experiment is done may be no more than asking him to perform a post-mortem examination. Maybe able to say how the experiment died. That's it. That's what I've got. Do you have any questions or discussions? I'm not actually sure who's online. No participants on video, but I don't know who's online.
I have a few questions.
Oh, okay, I'll try to answer.
Okay, the first one is, do we need a CTR grant or proposal to talk to you? Can
No.
we talk to you on any research we are doing? Or?
Absolutely. You saw that initial slide, so you can log in, do the consult. I'm trying to think. Most of the consults do not have external funding or internal CTR funding. That is, there are some projects that are pilot studies that have funding through CTR, or there's a few big data grants which have bigger funding. But most of the studies do not have either kind of funding. It's unusual to reject a request for a consult. So virtually all requests are accepted, because right now we have, I think, enough research. It's getting tighter, but we've been able to cover most requests. It is supposed to be translational research or community research. There are some ACE awards that are given out through Excel for community research. But most of the consults we have are not tied to funding. It's true. So, and it's easy to submit a consult, write it up, and we discuss new consults every Monday. It's rare that we have to skip a Monday.
Who's involved in consult? Everybody.
Oh, it's the Monday meetings we have are the Epi Biostat core. There are several key areas in the CTR Excel bigger project. Epi Biostat core is run by Bill Weintraub. And so it's epidemiologists and statisticians. So it's the Epi Biostat core that I'm aware of that meets every Monday. I'm not sure where the other ones meet, but we review the statistical or epidemiology concepts. Other questions?
How important is the sample size calculation for retrospective chart review? Because we really don't know much about
Well, how important? I mean, if you know ahead of time what you're trying to find, if you have a specific hypothesis, we can help you with the sample size, say how many charts you have to review. I'll say that sometimes we're asked to do calculations where you don't have a choice. You have a certain number of things, charts or subjects. You really don't have any flexibility about going. We can, before the end of the study, tell you about what you had power to do, but it's not really helping you with planning at all. We can just say that you don't have a great chance of success, or you've nailed it here. You have plenty enough data. But yeah, I mean, for a retrospective study, it can give you some guidance and stuff on like charts. Any other questions or discussion? Okay. And that's very good. And as you know, if you are submitting,
is there an agenda for the topics for every meeting, or do you know? Or should I?
So this meeting, I'm not familiar with this.
Schedule for the meeting.
I'm not familiar with this at all. I was just
The
asking
same meeting,
about collaborating with the staff.
October 21st today, which
And
is
if you're
today.
submitting for
on the
a
whiteboard.
CTR grant,
That's
like
scheduled for this
pilot
meeting.
study or something,
So
the
that's
requirements are to do
haven't
at
done.
least a
And November
consult
17th, we'll have
statistician.
another one.
Yeah,
But there's no topic.
That's what I wonder. Do we know the topic ahead?
They probably send us the email about the topic they're going to do.
I sent an email like a reminder, but they didn't know it was going to be about the.
Okay, well, I think we're done. I don't know how to actually turn this off, and I'll go ask Mary.
I will ask her.